The primary coil of a transformer has N1 equals 2 times 10 to the 10 squared turns, and its secondary coil has N2 equals 4 times 10 squared turns. If the input voltage across the primary coil is 180 volts sine omega t, what RMS voltage is developed across the secondary coil? Okay, so the first thing to notice is that they want to know the RMS voltage across the secondary coil. So it says RMS. What is the RMS voltage? But it gives us this crazy thing. 180 V sine omega t is across the primary coil. So if you remember that delta V is equal to delta V max times the sine, so the sine of 2 times pi times the frequency times time. I don't know why I wrote an S for sine, that's sine. Okay, so 2 pi times frequency is omega. So we got delta V, so delta V is equal to delta V max sine omega t. So what it's telling us is that it has given us the delta V max. So if you wanted to find delta V at some time, you could use this equation, but you would have to know what that time was. So in other words, it's telling us our maximum voltage is, in my case, it's 180 volts. So, and then it wants the answer in RMS voltage. So we got to do the primary RMS voltage. Delta V RMS is equal to delta V max divided by square root of 2. So the equation that relates the voltage, the ratio of the voltage in the number of turns, so delta V1 over N1, so the ratio of the voltage in the first circuit to the number of turns in the first circuit is equal to delta V2 over N2. And so all of these have to be in RMS, first of all, since I'm trying to solve delta V2 in RMS. And so I'll just solve for delta V2. So delta V1 times N2 divided by N1 is equal to delta V2. And I want this as RMS. And since I'm not given RMS, I got to plug in the equation right here. And so I get that delta V max over the square root of 2 times N2 over N1 equals delta V2 RMS. And so now you should be able to plug in your numbers and get the answer. I got that delta V2 RMS was 254.55 volts. Hey, thanks for watching. Make sure you check out my blog. The link is down in the About section of this video. And on the blog you'll find cool stuff like other videos for the same chapter. And you'll also find little download links where you can download calculators to basically just punch in your numbers and solve these exact problems. So you won't even have to watch the video if you don't want to. The last thing I want to say is if you leave comments on YouTube, of course I will get around to responding, but I'm much faster if you leave them at the bottom of my blog, right down there. Enjoy your day.